Welcome back to Low-Level Programming Crashcasts. I'm Sheila, and I'm here with Victor to dive into the fascinating world of assembly language. Before we begin, we'd love to hear from you. If you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. Your support means the world to us.
Absolutely, Sheila. Your feedback helps us improve and reach more programming enthusiasts. Now let's get started with today's topic. What is assembly language? This is the first section of our chapter on Introduction to Assembly Language, part of our broader exploration of low-level programming.
That's right, Victor. And to kick things off, I have a quiz question for our listeners. Here it is. What was the name of the first assembly language created in the early 1950s? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It really takes us back to the early days of computing. I'm sure our listeners will be intrigued to learn about the origins of assembly language. While we won't give away the answer just yet, it's fascinating to think about how far we've come in programming languages since then.
Absolutely. Now let's dive into our main topic. Victor, could you give us a basic definition of assembly language? I've heard it described as a low-level programming language, but I'm not entirely sure what that means.
Great question, Sheila. Assembly language is indeed a low-level programming language, but let's break that down a bit. It's a human-readable representation of machine code, which is the set of instructions that a computer's processor can directly execute. Each assembly language instruction typically corresponds to a single machine code instruction, making it very close to what the computer actually does.
That's interesting. So it's like a translator between human programmers and the machine itself.
That's an excellent analogy, Sheila. Just like a translator helps two people who speak different languages communicate, assembly language helps programmers communicate with the computer in a way that's closer to the machine's native language, while still being understandable to humans.
I see. But why was assembly language created in the first place? Couldn't early programmers just write machine code directly?
They could, and in fact, that's exactly what the earliest programmers did. But writing machine code directly was incredibly tedious and error-prone. Imagine trying to write a complex program using nothing but long strings of ones and zeros. Assembly language was created to make this process more manageable and less error-prone.
Wow, I can't imagine coding in pure binary. That must have been incredibly challenging. So, how does assembly language relate to the machine code it represents?
Great question. Assembly language has a one-to-one correspondence with machine code instructions. This means that each assembly instruction typically translates directly to a single machine code instruction. For example, an assembly instruction like ADD-AB might translate to a specific binary code that tells the processor to add two values together. It's like a word-for-word translation, but from human-readable commands to machine instructions.
That makes sense. But if assembly is so close to machine code, why don't we just use high-level languages all the time? What are the advantages of using assembly language?
Excellent point, Sheila. While high-level languages are more commonly used today, assembly language still has its place. The main advantages of assembly are: point 1. Control. It gives programmers precise control over the hardware. 2. Efficiency. When optimized correctly, assembly can produce very fast and memory-efficient code. Point 3. Understanding. It helps programmers understand how computers work at a low level. However, it's important to note that writing in assembly is more time-consuming and can be more prone to errors than using high-level languages.
I see. So it's a trade-off between control and ease of use. Are there any specific areas where assembly language is still commonly used today?
Absolutely. Assembly is still used in several areas. Point 1. Operating system kernels and device drivers. 2. Embedded systems with limited resources. 3. Performance-critical sections of programs. 4. Reverse engineering and malware analysis. 5. Some types of security-related programming. It's not as widespread as it once was, but it's still an important tool in a programmer's toolkit.
That's fascinating. It seems like assembly language is still relevant even in our world of high-level programming. Now, before we wrap up, let's return to our quiz question. Victor, would you like to reveal the answer?
Of course, the answer to our quiz question is, the first assembly language was called short code, developed in 1949 for the BNAC computer. However, it's worth noting that some consider RC assembly for the ARC computer in 1947 to 1948 as the first true assembly language. Both were pioneering efforts in making programming more accessible than raw machine code.
Thank you, Victor. To summarize today's episode, point 1. Assembly language is a low-level programming language that closely represents machine code. Point 2. It was created to make programming easier than writing raw machine code. Point 3. Assembly has a one-to-one correspondence with machine instructions. Point 4. While less common today, assembly is still used in specific areas where precise control or performance is crucial. Thank you all for listening. If you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, happy coding.